Hello everyone. In this video, we are going to learn about latent heat. Do matter exist in all the three forms? Or can we change the state in which matter exists? What happens inside the matter during this change of state? What happens to the particles of matter during this change of state? How does this change of state take place? To find an answer to all these questions, let's perform an activity. We have taken a few ice cubes in a beaker and put a laboratory thermometer into the beaker. Now, let's heat the beaker on a low flame. Note the temperature when the ice just starts melting. Let's heat it till all the cube melts. Almost half of the cubes melt, but the temperature is not changing. Now, almost all the cubes melt, still temperature is 0. And now we see the temperature starts increasing. Let's heat it further until we see a gradual increase in temperature. Now, it becomes 100 degrees Celsius and vapors start forming. But again, the thermometer reading is constant at 100 degrees Celsius. Let's keep on heating. Surprisingly, the temperature is constant and the volume of water in the beaker is decreasing. When all the water in the beaker gets vaporized, the temperature again starts increasing. Now, let's explain our observations. On increasing the temperature of ice, the kinetic energy of the particles increases. Due to the increase in kinetic energy, the particles start vibrating with greater speed. The energy supplied by heat overcomes the forces of attraction between the particles. The particles leave their fixed position and start moving more freely, and a stage is reached when the ice melts and is converted to liquid water. In general, we call the minimum temperature at which a solid melts to become a liquid at a given atmospheric pressure as melting point of their substance. The melting point of a solid is an indication of the strength of the forces of attraction between its particles. The melting point of ice is approximately 0 degree or 273 Kelvin. The process of melting, that is, change of solid state into liquid state, is known as fusion. Similar situation comes into play when we are heating liquid water. When we supply heat energy to water, particles start moving even faster. At a certain temperature, a point is reached when the particles have enough energy to break free from the forces of attraction of each other. At this temperature, the liquid starts changing into gas. In general, we call the temperature at which a liquid starts boiling at a given atmospheric pressure as its boiling point. We see boiling is a bulk phenomenon. Particles from the bulk of the liquid gain enough energy to change into vapor state. For water, this temperature is 373 Kelvin. See, interestingly, you must have noticed that the temperature of the beaker was not changing when the ice was melting and when the liquid was being converted into gas, even though continuous heating was supplied. What happened to the heat? This heat gets used up in changing the state by overcoming the forces of attraction between the particles. As this heat energy is absorbed by ice in the first case and the liquid water in the second case, without showing any rise in temperature, it is considered that it gets hidden into the contents of the beaker and is known as latent heat. The word latent means hidden. So, particles in water at 0 degree centigrade, that is 273 Kelvin, have more energy as compared to particles in ice at the same temperature. And similarly, particles in steam that is water vapor at 373 Kelvin, that is 100 degrees centigrade, have more energy than water at the same temperature. We define the amount of heat energy that is required to change 1 kilogram of a solid into liquid at a given atmospheric pressure at its melting point as the latent heat of fusion. Again, the amount of heat energy that is required to change 1 kilogram of a liquid into gas at a given atmospheric pressure at its boiling point is known as the latent heat of vaporization. Now, is it possible that we can transform a gas into liquid or a liquid into solid by lowering the temperature? Think about it. Yes, it is indeed possible by lowering the temperature. When a gas or a liquid is cooled, the particles lose much of their kinetic energy. So they slow down and come close. Their interparticle forces of attraction increases, and thus the state changes into liquid or solid respectively. The process of changing a gas or vapor to a liquid by cooling is called condensation, and the process of changing a liquid into solid by cooling is called freezing. One thing to keep in mind is that during the process of condensation, amount of heat released is equal to the latent heat of vaporization that is given out. Similarly, during freezing, amount of heat released is equal to the latent heat of fusion. We have a home task for you. You have to explain why ice at 0 degrees centigrade is more effective in cooling than water at the same temperature. So that's all from today's class. See you in the next class.